Hello, welcome back to the lecture series on microeconomics. Earlier we have seen how to find equilibrium of a simple monopoly model and a third degree price discriminating monopoly model. Now we are going to revisit those models with the help of a numerical example. I hope this numerical example will help you to understand these models in greater detail. So, first we are going to start with the simple monopoly model. Where the monopolist cannot divide the market into two or more homogeneous consumer groups. So, basically it assumes that the market is uniform. So, we start with the market demand function of the form. I must say all these numbers that I am using here in this numerical exercise are hypothetical in nature. So, if you change these numbers, of course, the solution will change. So, from this direct demand function I can now get the inverse demand function, which is equal to P equal to 100 minus 2 q. Let me name this equation 1, right. So, this is basically my inverse demand function. For the entire market. Okay. So, now let us also going to have a cost function. So, the total cost function has the following form: C equals 100 plus 20 q, right. Okay. So, now from this demand function and the cost function, one can note down the profit function of the monopolist could be written as total revenue minus total cost, right. And how do we write the total revenue? The total revenue will be P times Q minus this 100 plus 20 q, that is the cost component, right. Now, we need to use the inverse demand function expression number 1 in this profit expression, and if we do so, we get right. So, the revenue function, if I expand, it will become 100 q minus 2 q square, and then of course, I have this 100 plus 20 q cost component, right. So, this is my profit function. So, let me use this equation number 2 to have my profit function. This is my objective function as well, which the monopolist would like to maximize, right. Okay. So, now we are going to study the steps which are required to get the solution to this particular problem, right. So, we will start with step number 1, and in step number 1 we need to find out the marginal revenue curve, right, because for the first order condition of monopoly's equilibrium requires MR equal to MC, right. So, the first task at hand to find marginal revenue expression. How to get the marginal revenue expression? From the total revenue we can get the marginal revenue, right. So, my TR is basically 100 times Q minus 2 Q square, right. So, from here I can simply take derivative with respect to the decision variable, which is basically the output level, and I get 100 minus 4q, right. So, this is basically my marginal revenue, right. Okay. So, now what would be the second step? Second step is to find out the other part of the first order condition of monopoly equilibrium, and that is basically the marginal cost, right. So, again we start with our total cost function. So, that is basically 100 plus 20 q, right. So, if I take derivative with respect to quantity to be being produced, I get 20, right. So, that is basically my marginal cost. So, here we get a constant marginal cost in this simple example. Now, let us go to step 3, and here we now concentrate on the first order condition. So, we need to equate MR and MC expressions that we have got, and if we do so, then basically we get a value of q for which these two are equal, and that value is basically monopolist's profit maximizing output level, and this is here q star equal to 20. Okay. Now, once we have obtained the quantity, optimal quantity or production or output level of the monopolist, the next step is to find price. And if you remember from our discussions on monopoly, one has to go to the demand function and plug this value of optimal quantity in it to get the optimal price that the monopolist sets in the market, right. So, if we plug this q star equal to 20 quantity or output level in my expression number 1, which is my inverse demand function, then basically I get P star equal to 60, right, from 1, the inverse demand function. Okay. Now, the next important thing, although optional, is basically find the monopolist profit. Okay. So, to find profit, we have to make use of the profit expression, which is basically my expression number 2 here in this example. So, as I am plugging the optimized values of q and p in the profit expression, I write optimized profit or maximum profit pi star as 60 times 20 minus 100 plus 20 times 20, right, and we get a profit level 700. Okay. So, we have obtained the profit figure of the pure monopolist in our example. Now, there is another interesting case that one can discuss in terms of this numerical illustration, and that is the case of tax imposition by government. So, now we are going to impose unit tax, say rupees or dollar, whatever, we have not assumed any monetary unit. per unit of monopoly output, right. And basically the interesting question that we are going to also address is the following: what will be the implication on deadweight loss if government imposes tax, any type of tax. We are going to study the implication of unit tax only. Okay. So, now if we assume a particular value of unit tax, then how profit equation of the monopolist is going to change. So, we are going to rewrite the profit expression. So, it is going to be this is the revenue part, right, then cost will be deducted, right, and then the tax that the monopolist has to pay to the government shall also be subtracted from the revenue, right, and that is 4q. So, if we now look at the first order condition for monopolist's profit maximization problem, we get what? We get d pi dq equal to 100 minus 4q, right. So, that is basically the marginal revenue part, right. If you remember, so this part is coming from the marginal revenue part, okay. And then there will be this marginal cost. So, marginal cost, and then finally 4 will come, and that is basically the tax element, right. So, this is basically the marginal revenue, and then this is basically the tax, right. Okay. So, now we can set that equal to 0, and then from there if we solve for q from this first order condition, we get what? We get q star, and I use T subscript to denote the equilibrium output of monopoly after tax imposition. So, that basically becomes 19. Okay. Note that last time we have obtained q star equal to 20, that is the pure monopoly output without taxation. So, let us now draw a diagram to understand what is exactly happening here. Okay. So, this is my monopoly output q, okay, and I plot my marginal cost and marginal revenue etcetera here along the vertical axis as usual. So, let us first plot the demand function. Okay. So, here the demand function has an intercept of 100 along the MRMC or along the vertical axis, right. So, let me first have that, and given the demand equation, we know that its horizontal axis intercept will be 50. Okay. So, let me create some room here for numbers, okay, 100. Okay, fine. So, then comes the marginal revenue curve. So, we know that marginal revenue curve will start from 100, and as there is this relationship of a linear demand function, we know from there that the slope of the marginal revenue curve will be exactly half of the demand curve from which it is derived. So, by following that logic, we know that the quantity at which marginal revenue will become 0 is 25. So, let me join these 2 points and then I get my marginal revenue curve, right. Of course, there will be a negative extension, but we do not want to draw it because this is irrelevant for all practical purposes. So, this is my demand, right. Okay. So, now let us plot our marginal cost, and the marginal cost is basically a constant number which is 20. Okay. So, let me plot that. This is my marginal cost curve MC, and the value is around 20, right. Okay. So, the competitive market equilibrium is basically obtained at this intersection point A, where the marginal cost or the supply function intersects the demand function, right. And we can solve for the perfectly competitive equilibrium output, because that is required for deadweight loss calculation. So, and we find that number to be 40. Okay. And now the intersection of MC and MR will be denoted by this point B, and that is basically my monopoly equilibrium, and we have found that this monopoly equilibrium quantity level is 20, right. Okay. Now, what happened? There is a tax imposed by the government, right. So, the tax is 4 units. So, let me assume that there is a parallel shift of the marginal cost curve, and this gap is basically my tax, and the intercept will be then 24. So, this curve is now MC plus tax. Okay. So, another monopoly equilibrium will be found here at this intersection point of new shifted marginal cost plus tax curve and MR curve, say point C, and we have also solved for the output level which corresponds to this new equilibrium of monopolist firm, and that is 19, right. So, this is more or less the picture. Now, how to compute the deadweight loss, that is the question. So, now let us see what is the deadweight loss area in the monopoly case. So, we need to compare the equilibrium A and equilibrium B, and we know from our definition of deadweight loss, it is given by this triangle shaded by this blue lines. So, that is basically the deadweight loss due to the pure monopoly. Now, if the government imposes a tax to penalize monopoly, monopolist finds its new equilibrium, and at this new equilibrium it actually produces even less units of output. So, actually the market level of output declines from 20 to 19. So, basically the deadweight loss area increases, and now the increased deadweight loss area is given by this triangle shaded by these purple lines, right. So, after we found out the equilibrium quantity levels, we have to figure out the prices, right. So, in the case of monopoly we have seen that the market equilibrium price charged by the monopolist was rupees 60, it was set here. Now, after the tax imposition, basically we have to move up from this point C and we have to read the price from the demand function, and if we do so then we get market price 62 which shall be charged by the monopolist, right. Okay. So, now we are ready to do our deadweight loss calculation. We will basically compare two deadweight loss numbers and look at the measure the difference. So, component number 1 will be the deadweight loss due to presence of monopoly in the first hand, and we know how to compute. We have to use the simple formula of area of a triangle, that is half times base times height, right. So, we can apply that formula to get 400 rupees or dollar whatever deadweight loss. So, this 40 is basically coming from the difference between the perfectly competitive market price and the monopoly price, and this 20 is coming from the difference between the perfectly competitive market output level and the monopoly equilibrium output level, right. Okay. So, now let us go back to the deadweight loss calculation, this time for monopoly plus tax case, right. So, we have to use the same formula and this time it will be 42 times 21. So, this 42 is coming from the difference of perfectly competitive market price and the price of the commodity charged by the monopolist after tax imposition by government, and this 21 is basically the difference in the monopoly equilibrium output level after tax imposition and the perfectly competitive output level. So, this comes out to be 441 rupees or dollar. Okay. So, basically the change in deadweight loss is about rupees or dollar 41, right. So, we see that there is an increase in deadweight loss following tax imposition by the government. It is because that anyway we had some market imperfection to start with due to the presence of monopoly. On the top of that, government imposed the tax and that created another market imperfection, because the perfectly competitive market assumes zero intervention by the government in the working of a perfectly competitive market. So, this is the way we have found the monopolist equilibrium quantity level, price and the profit. Now, let us look at another numerical example which talks about the third degree price discriminating monopolist. We know that a third degree price discriminating monopolist actually can successfully discriminate between various consumers. So, the monopolist for sure knows that there are homogeneous subdivisions of the consumer population and each subdivision of consumers has different price elasticity. And now, if we assume that this is indeed the case, how the monopolist goes about profit maximization. So, next we are going to look at that through the numerical example. Okay. So, in this case let us assume that there are two consumer subgroups with different price elasticities, right. So, for these two different subgroups we will have two different demand functions then, and they are given as q1 equal to 32 minus 0.4 p and q2 equals 18 minus 0.1 equals p, 18 minus 0.1 times price. Okay. So, now note that I have chosen to sub market demand functions in such a way that q is q1 plus q2. So, if I add these two subgroups demand functions, I get the original demand function with which I started my first numerical example. So, I can now find the inverse market demand functions for these two consumer subgroups, right. So, if I do so, then I get as the monopolist will discriminate and charge different prices in different markets. Now, I am going to use the suffix 1 and 2 for my price and quantity levels, right, compared to my previous example. So, now we are going to assume the cost function. So, we take the same cost function and there is a reason for choosing the same cost function. So, that we can compare the profit levels between the pure monopoly model and the price discriminating third degree monopoly model. So, the same cost function means that we have this T c is 100 plus 20 q, right. Okay. So, now let us proceed step by step. So, first we are going to write down the profit expression. So, profit will be the revenue from market 1 plus revenue from market 2 minus the total cost of production. So, we have seen how to derive the revenue function. So, I am not repeating each and every step, I am just giving you the final outcome. And then finally, I have to subtract the cost right. Okay. So, now step 2 would be to derive the marginal revenue curves, right. So, here there will be two marginal revenue curves because we are talking about two different markets, right, and each market has a different demand curve. So, I give you the final expression of the marginal revenue curves in these two markets, okay, and I name this number 3 and 2 equal to 180 minus 20 Q2, that is my number 4 expression. Okay. Now, the next step is to find my marginal cost of production, right. Now, note that I can write so we get the same constant marginal cost back. Okay. So, next step what to do, we have to equal to this individual marginal revenue curve expressions to the marginal cost, and hence we get the equilibrium. So, we first equate MR1 to MC, and if we do so we get 80 minus 5 Q1 equals 20. If we do so, then we get a Q1 star value of 12. If I now equate my marginal revenue curve from market 2 to the MC, then I get and of course, I get some value of Q2 which solves this equation. So, note that I got my optimal means profit maximization, output, supply, or you can say production, for 2 markets, right. Now, note that interestingly, if I now sum them up, I get the total market supply which is Q star equal to 20, and this was indeed the case in my example 1, where we discussed the case of a pure monopolist. Okay. So, now let us move on. We know that the monopolist is a third degree discriminating monopolist. So, our firm, so we know that our monopoly firm is a price discriminating one of third degree. So, the next step would be to find different prices to be charged in different markets. So, once we get these optimal levels of Q1 and Q2, we can plug back these numbers in the individual inverse demand functions. So, we can plug these numbers Q1 star and Q2 star into my inverse demand functions, which are given by equation 1 and equation 2, right, to obtain the optimum prices to be charged in 2 different markets, right. And if we do so, then basically we get okay. Now, the last step which is required to show you that if the monopoly is able to discriminate, then it actually attains higher profit compared to a normal monopoly model. For that we need to compute the profit, right. So, last but not the least, we have to compute the profit level. So, let us now plug the optimum values of P and Q, and compute the profit level, right. So, if we compute, it is going to be 900. So, if you remember our theoretical discussion on monopoly, you may remember that there is a relationship between the own price elasticity of demand and the prices to be set in individual markets if there is price discriminating monopoly model is in operation. So, that is what we are going to check. So, we have got two different prices and two different quantity levels for two sub markets. Let us check whether indeed the price elasticities are different or not. So, now let us compute these price elasticities. Okay. So, E1 is basically the own price elasticity of demand for the market 1, and we know how to compute. This is not a very difficult task, right. So, this is the formula, right. Similarly, we can write okay. Now, these expressions are to be evaluated at the equilibrium point in each market, right. So, if we consider the market number 1 to start with, then these are the numbers So, this is basically the negative of the slope of the demand function, and this is basically the optimal price, and this is optimal quantity level, right. Okay. So, the final number that we get is around 1.66. Now, let us come to E2, and similarly we take the negative of the slope of the demand function times the optimal price divided by the optimal quantity, right. Okay. And if we compute, this is coming around 1.25. Okay. So, now we have seen here that elasticity of demand at the equilibrium in market 1 is greater than the price elasticity of demand evaluated at the equilibrium in market 2, and we see that P star 2 is greater than P star 1. So, here we see that price charged in market 2 is greater than price charged in market 1, but note that in market 1 basically the price elasticity of demand value is higher. Okay. So, with this numerical illustration we are done with our discussion on monopoly models. So, we have seen so far two extremes where we have large number of sellers, that is the perfectly competitive market model, and the other extreme is basically the monopoly model where we have only one seller. So, in the first case one seller's strategic move to produce some units of output more or less does not have any influence on the market outcome that we have seen, and in the other case we have seen that if there is only one seller, then there is nothing to worry about competition because you are the king in the market. But there can be intermediate cases where there could be two or more number of sellers, but the number could be less than 10. So, basically each and every individual firm or seller has some significant portion of the market to serve, and in that case there are chances of strategic interdependence. So, if firm 1 thinks that if he chooses a strategy A, then the opponent firm is going to choose a strategy B, and if that happens then firm 1 is going to get some monetary reward X, Now, there is also a possibility that if the first firm chooses a strategy C, then the opponent firm will choose a strategy D, and hence as a result the first firm will get some monetary reward Y. So, this is basically the field of oligopoly, where oligopoly means few sellers, and next we are going to discuss these types of model. So, we will continue our discussion on imperfect competition market in the next lecture.